Okay, today we'll be discussing about the work done, and to know the work done, very first we should have idea about can what work can be. What is work? Work is the scalar product of force and displacement. A scalar product of force and displacement. Though both of the quantities, the force and the displacement, are the vector quantity, but the work we get is scalar quantity. Those both are the vector quantity, but this is a scalar quantity. And what do we mean by this is the these two are the vector quantity and this is the scalar? Not only we look at the dot product, but the work can not directional. It cannot directional. It means the work has to be either on the body, or by the body, by the body. There are two scenarios: the on the body or by the body. If it is on the body, then it has to be positive, and by the body, then on the body is negative, by the body is positive. In this way, we categorize the work done. Now, as we know, work is the product, scalar product of the F and S, and further, what is the magnitude is F dot S dot cos theta. So, as the work is now product of force and displacement and cos theta. So, if let's say you have a force of certain units, suppose you have a Newton force in this direction, and same time, or let's say you have a toy car, and if you pull this car in this direction at a particular force, say B Newton or B vector, and it displaces by A vector. It may be confusing, but the intention to this A and B here is how much this toy car is being displaced in this direction, and how much the force, which is not exactly with the horizontal but having some angle with the horizontal, then what is the component of this force working in this direction. And well, we know we already have done A dot B, and that is what A dot B cos theta. This is the theta between them. And that will give you a work in term of joule. If we say if there is another component of this one, as it is the in I direction, and if it has this force has this force, a B vector has this is A cos theta in this direction, and in this B cos theta, and in this direction it is B sin theta. So how much this is impacting, how much this force is working in this direction, that is, if the net work we calculate work in the y direction and work in the x direction, that is work in y direction and work in x direction, that can be, this is A B cos theta, and that must be A dot B sin theta, and this one B sin theta dot 90, what is the angle between these two? So that is 90 degree and cos 90 degrees. So this part becomes the whole 0, and there we are left with AB cos theta. So the net impact of this vector or this force in the direction of the displacement is AB cos theta, and this component actually is not sharing any part in this direction, so it becomes a 0. So the net work done is this plus 0 is AB cos theta joule. AB cos theta joule. So there are kind of force actually in physics we see, and how the force can be positive, negative. It cannot be fixed like force is positive. It can have a different impact. Say there is a lift, and there is something in the lift and this lift normal is working up way and the lift is going down the way. This is velocity working down the way. Then the force, then the work done between these two component, or work done, net work done by this lift is the force, that is the force in, you can see the direction between this force and displacement is almost cos phi, which is 180 degree. As you can see, the angle is 180 degree, and hence the work done is negative Fs. You can see the work done here in this case is negative. Okay. In the second case, if the lift is moving down with the velocity v, and normal is also working down the way, and if the lift is going up and normal is working down the way, then we see the force and displacement both are working in the same direction, and the angle between them, as you can see, this is the force vector, normal vector, and this is the velocity vector, both has the same direction. The net angle between them is 0. The angle between them is 0. See, if this is a certain line and then x-axis, and this is angle theta, or you always measure it anti-clockwise. So what is, if this line coincide over the same line, and these two lines working in the same direction, so angle between them is 0 degree. And what is our work done? Work done is nothing but, here in this case, Fs cos theta, and that cos theta this time is 0, so W is Fs as cos 0 is 1. So here in this case, work done is maximum work will be done in this case when the force and the velocity are in the same direction. Okay, take another case. If let's say if the lift moves in this direction, and this is the displacement direction, say, and there is the normal reaction, then the angle between the normal and the velocity is 90 degree, so it is Fs cos 90, and in this case the work done is going to be 0. So we have seen how the work can be categorized with respect to normal depending upon the different the angle. If the angle between the velocity and normal is 180 degree, the work has to be that is negative, and positive in this case. When it is along with the same, the work is the force is along with the velocity, and if it is perpendicular, the work becomes 0. Now, what do we get from this? What do we observe from this? The work done is W is equals to Fs cos theta, and here we say theta has three different. We can divide theta into three different categories. Either theta is equal to 0, or theta is greater than 90, or theta is greater than 90 or less than 180. There are three different aspects. So in first case, if theta is 0, we say W is equals to Fs cos 0 is 1. So W here we get is max, that is force into displacement. The complete displacement vector contributing 100% to the force vector, so you get the maximum work done here in this case. Okay, in this case, if we see the theta is less than 90, what does it mean? Less than 90 is, it means it is 90 to 0. And including 0 but excluding 90, it can be 89.99999. In that case, you will see the work is positive. Say W is equals to Fs cos theta, and cos theta in the first quadrant, as we see in the first quadrant from 0 to 90, not included 90, but 0 to 90 is always give you some the fractional number, and W here becomes max Fs. What in case of greater than 90? Greater than 90, including 90, then including this what? Greater than 90. What at 90? First we will say theta is equals to 90 degree. exactly theta is equals to 90 degree. In that case, W is equals to Fs cos theta. Here W is equals to F is F dot S, and cos 90 is 0. So your work done is 0. In that case, work is 0. Okay, the fourth one, if the angle between the force vector and displacement vector becomes greater than 90 degree, not even greater than 90 degree, in that case, as we know, in the second quadrant the cos theta is negative. In the second quadrant cos theta is negative, then W is equals to negative Fs, and here we get the work done negative. Okay, further we have the work done with respect to, actually work have a different